Welcome back, folks. In today's class, I'll continue talking about the concept of energy and the power. So if I divide energy with time, that's going to give me power. And this can be any form of energy. It can be potential energy, it can be kinetic energy, it can be any form of energy. If you divide by the time, that's going to give you power. Now, let's look into a question based on power. So there is a car given to us which has a mass of 2000 kg, is traveling up the hill at a constant speed of 90 kilometers per hour at 25 meters per second. The force of air resistance which opposes the motion is 450 Newton. The slope of the hill is 6 degrees. Draw the free body diagram to show the external forces acting on the car. First of all, so this is the slope and the degree of the slope is 6 degrees. There is a car and this is the car which is moving up the hill. So if the car is moving up the hill, then there will be an applied force up the hill, force applied. And then there will be an opposite force, that will be force of friction. Now, I'm not going to take the vertical forces because I don't want you guys to feel confused. We're only going to talk about the inclined forces or the horizontal forces. Those horizontal forces are at an inclined angle in this example. So thus I will call it as a horizontal or inclined, whatever you want to call it, you can use that name for it. But I'm not going to talk about the vertical forces in this free body diagram. And that's totally okay because we end up balancing these inclined forces which are occurring on the body at an angle. And now the force of friction, which is equal to mu mg cos theta. But in this case, if I look back in the question, we are provided with the force of friction that is equal to 450 Newton. 450 Newton. And then there is another force which is acting on this one that is equal to mg sine theta, which will act always in the downward direction. So that is this one, mg sine theta. So this is, I've talked about this concept in the chapter number 3 also, where I've talked about the forces. So if you wanted to understand it in detail, you can go back. Otherwise, I'll write down the equation. This is the generalized equation. F net is equal to force applied plus minus force of friction minus mg sine theta. This is the equation which we've learned. Now, and this is along the inclined plane. Now, net force, if I look into this question, the net force is how much? It is moving at a constant velocity. So net force will be 0 because F net is equal to, I'll write it here, F net is equal to ma if acceleration is 0 because it is moving at a constant velocity. So I can mark this one as 0. So I've drawn the free body diagram and I've written down the equation also. Force applied plus minus force of friction minus mg sine theta. Now let's look into the part B and C. So determine the forward force needed to maintain the car speed. We wanted to find out the forward force. What does that mean? That means we are looking for the applied force. So applied force in this case will be equal to, this force of friction will act in the downward direction because the body is trying to move in the upward direction. So this will be minus 450 newtons and minus mass times, which is 2000 times 9.81 times sine of 6 degrees. And then what you're going to do is, these both are negative forces. You're going to add up these and move it on the other side. And you will find that force applied value will come across as, let me do the calculation on my side. So that will be 2000 multiplied by 9.81 times sine of 6 degrees. This value is 2050.84 and this is 450. This is force applied and this is 0. Now these two I will add up. this number plus 450, that's gonna be 2500 approximately. So 2500.8 newtons. That's the applied force which I calculated. And for this is the force required to move the object in the forward direction. Assuming all the power output of the car engine goes to maintain the car's forward direction, calculate the power output of the engine. Okay, so it means it says that there is no loss, that all the power output of the car engine goes in maintaining the car's forward speed. That means efficiency is 100%. Efficiency is equal to output upon input. I'll talk about it some other time. So, but I just wanted to give you a gist of what does this line means. That whole of the energy which is being produced by the engine, that is being utilized, no losses. So now power is what we are looking for. Power is equal to, oh, we are given only force. How can I find the power? Power in that scenario, again, we're stuck now. We don't have any formula, but I have to make a formula in terms of force. So I'll show you how can we make a formula. So work done is equal to force times distance, and work is equal to energy. And energy, if I divide energy with time, so energy divided by time, that means work divided by time, that means this divided by time. So force times distance moved divided by time, that's going to become force times speed, because distance divided by time is speed. And now energy divided by time is power. So power equal to force times speed. So that is 2500 or 25,000 we got. So it was 2500. So 2500 multiplied by 25, and that's going to give you 6.25 times 10 raised to the power 10 raised to the power 4 watt. That is the power output, and I can write it in kilowatts also. 62.5 62.5 kilowatts. 1 kilowatt equal to 1000 watt. So hopefully you understood this question, and this helped you to understand the concept of power. And I'll see you with another video. Till then, goodbye.